Hi everyone, this is Dr. Orkun Baycik, and today we are going to talk about how to mathematically formulate a given problem. So we are going to make an introduction to mathematical modeling. The first example is going to be a small, fairly simple manufacturing example, and in the upcoming videos we are going to look at more complicated problems, and we are going to see how we can formulate them as well. So in this problem, the first step that you need to accomplish is to clearly understand what the problem describes. Okay, I would recommend underlining the important parts or taking notes when you read the question, especially when you first start working on mathematical modeling questions. So we have a manufacturer that produces different types of furniture, and they recently decided to focus on two of the most popular items, which are the dinner tables and sectional sofas. Each dinner table requires a total of 6 hours of carpentry and 2 hours of finishing work. Okay? So this is important. Each dinner table requires a total of 6 hours of carpentry and 2 hours of finishing work. Okay, so these are important. Each sectional sofa requires a total of 10 hours of carpentry and 10 hours of finishing work. So this is another important set of information. So 10 hours of carpentry and 10 hours of finishing work. Okay, so I underline them to keep that in mind. Currently, the total amount of time that can be allocated to carpentry is 200 hours. So this is also an important information. Remember from the previous paragraph, we know that these items require a certain amount of carpentry work. And this sentence tells me that we have an available 200 hours carpentry work. Next, the time that we can allocate to finishing work is 160 hours. So the available finishing work hours is 160 hours. So these are important as well. The company makes a profit of $750 per dinner table and $2,000 per sectional sofa. Okay, so these are the profit amount for the dinner table and the sectional sofa. So these are also important values. The manager of this company aims to determine how many dinner tables and sectional sofas to produce to maximize the profit. Okay, so this sentence is very important. I'll just create a new paragraph with it. The manager wants to determine how many dinner tables and sectional sofas to produce. Okay, so determine is the keyword. How many dinner tables and sectional sofas to produce? So this sentence starts by telling you what our main decisions are. Okay, so we want to determine how many dinner tables to produce and how many sectional sofas to produce. Okay, so these are important. And then the sentence ends by telling us what our objective is, which is to maximize the profit. Okay, so this is important. We first decided what are the decisions to make, and then second, we identified what the objective is. Okay, so these are important. So when we talk about a mathematical model, we in general have 4 different components, and those components are the parameters, the constraints, decision variables, and an objective function or objective functions depending on the problem, but we are going to focus on the problems that have only one objective function for now. So first of all, since this is the first video about mathematical modeling, I will spend more time on how to get ready to model the problem. So first of all, I'm going to list what my parameters are. Okay, so what do I know? Parameters represent what we know, what is given in the problem. Okay, so we know the time required for carpentry and finishing for the tables and sofas. Okay, so this is given. We know how much time is required for carpentry and finishing for the tables and sofas. Okay, those are the ones that I underlined in paragraph 1. And in addition to these, we also know how much available carpentry and finishing hours we have currently. Okay, so the second one will be the total amount of available carpentry, sorry about that, carpentry and finishing hours. Okay, so from the second paragraph, the highlighted areas tell us we have 200 hours of carpentry and 160 hours of finishing work hours available. And then last, we also know the profit amount for each table and each sofa. So the profit amounts for tables and sofas. Okay, so these are also given. So these are the values that the problem gives us. Okay, these are known, these are given, and they are called parameters. The parameters show up in your constraints and in your objective functions. Okay, next I'm going to list my I'm going to write down what my objective is. So the objective is given in the question clearly, and that is to maximize the profit. Okay? And you can also do the same thing for the constraints by writing down constraints, and we have 200 hours of carpentry, we have 200 hours of available carpentry hours and 160 hours of finishing hours. Okay? But to save time, I'm not going to type them. And next step is to write down the decision variables. So again, from the last paragraph here, I already underlined that sentence that starts by telling us what the decisions are. Okay, so we are going to get started with the mathematical model now. So we are going to start defining our decision variables. So we have two decisions to make, right? The first one is to determine how many dinner tables to produce, and the second one is to determine how many sectional sofas to produce. So what I do for this is to define a decision variable, x1, which represents the number of tables to produce. Okay? The number of tables to produce is x1. And I'm going to copy and paste it and change it to x2 and modify this so that x2 defines the number of sofas to produce. Okay? So number of tables to produce, number of sofas to produce are the things that I want to decide. Okay? So this is important. And then I'm ready to write down my mathematical model. So mathematical model. A mathematical model starts by writing down your objective function. Okay, so I know what my objective is, but I need to write my objective function now. The objective is to maximize the profit. So let's write this down by using math. So x1 is the number of tables to produce. How much money or how much profit am I making per each dinner table that I sell? That is given in the question, which is $750. Okay, so if I multiply 750 by x1, that will give me the amount of profit I make by selling a certain number of tables. Okay, so I'm going to maximize the profit from dinner tables plus the profit from sectional sofas. The 750x1 represents the profit I make by selling dinner tables. Similar idea, I need to find the profit per sofa that we sell, which is $2,000 given in the problem. So 2,000 times x2. Okay, so for example, if I sell one table and one sofa, my profit will be 750 times 1 plus 2000 times 1 equals 2750. Okay, so this is how the objective function is written. And then we are going to start writing down our constraints. So we start by writing our objective function subject to our constraints. So the next step is to type subject to, and then we will list our constraints. So the second paragraph, the highlighted area here, these two rows, are important regarding the constraints because they tell me how much carpentry and how much finishing work hours we have available. Okay, so each item that I have requires certain number of hours of carpentry and finishing work, but I only have so many carpentry hours and so many finishing hours available that restrict the number of tables that I can produce. For example, each dinner table requires 6 hours of carpentry, okay? And I have 200 hours available. Let's ask ourselves, can I produce 100 dinner tables, for example? So let's write it down and I'll remove it in just a little bit. If I produce 100 dinner tables and each table requires 6 hours of carpentry, how many hours of carpentry hours do I need? The answer is 100 times 6, which is equal to 600 hours. So if I want to produce 100 dinner tables, I need 600 carpentry hours because of this requirement. However, I only have 200 hours available. Okay, so and 600 is greater than 200, which is not feasible. Okay, so this is not feasible. We cannot produce 100 dinner tables. Okay, so the mathematical model will look at the bigger picture by including every constraint, but this is just an example to explain what the constraints are for in our models. Okay, so I'm going to remove this because I don't need them in my model. But first, I have a carpentry hour constraint. So I need to list how many hours the carpentry takes for each dinner table. It's given in the first paragraph, which is 6. So I'm going to write 6 times x1. So this represents the amount of time we spend on carpentry for the total number of tables we produce. And the sofas also require carpentry work, which is also given here as 10 hours. So it's going to be 10 times x2. Okay, so this sum here gives me the total amount of carpentry hours that I will need to produce these furniture items. And this sum must be less than or equal to 200 because I only have 200 hours of carpentry time available. Okay, and in parentheses, I'm going to write down what this constraint represents. Again, since this is the first video about mathematical modeling, I will do this by showing all the details, but in general, I would say that decision variable definitions, mathematical models would be sufficient. So you don't necessarily need to write these down in details. Okay, but I usually like to have the details about the constraints in parentheses to give the reader what those constraints mean. So this was for the carpentry hours, and then the second part of the constraint is the finishing hours. Okay, so each dinner table requires 2 hours of finishing work. So if I write 2 times x1, this will give me the total amount of finishing work done for each table we produce, plus each sectional sofa requires 10 hours of finishing work. So 10 times x2, the sum here gives me the total amount of finishing work hours. Okay? And similar to the first constraint, this has to be less than or equal to 160 because I only have 160 hours of finishing work available. and in parentheses, I'm going to write finishing hours. Okay? So these are the constraints defined by the problem. And we have one more set of constraints which the students usually forget about, but you definitely need to include them in your mathematical models. And those are called the sign restrictions. So let me ask you a question. Can you produce -1 dinner table? Can you produce -10 dinner tables? Can you produce -100 sectional sofas? You cannot, right? So it has to be either 0 or a positive amount. So for that reason, we add the sign restrictions, which enforce that the number of tables produced, number of sofas produced will be greater than or equal to 0. Okay, so I can choose to produce 0 sofas, but I can't do anything negative. Okay, so this is what it enforces. So this completes this mathematical model. Okay, so the model here, maximize this objective function subject to our constraints, is our mathematical model. But one more note that will be important in the upcoming videos is to identify what type of decision variables we have. So another question that you will need to ask yourself is, can I produce a fractional number of, for example, dinner tables or sectional sofas? For example, can you produce 0.7 dinner tables? Can you produce 2.4 sectional sofas? You cannot, right? It has to be an integer value. So for those situations, we specify these values to be integer in parentheses. Okay, so for now, just because this is the first video about mathematical modeling, it's not crucial, but when it comes to modeling integer linear programs and solving them on Excel or another programming language, it will be crucial to identify and define the type of decision variables you have. Okay, so for this type of problems, obviously you will need to have integer decision variable values when you solve your model, and therefore in parentheses you put this note that they are integer. Okay, so this will complete this video, but in general the goal in this video was to kind of introduce you how to model a given problem mathematically. Okay, in the upcoming videos we are going to use this mathematical model and solve it on Excel solver to find optimal solutions for us. Okay, for example, yes, okay, I have this mathematical model here, but what do I need it for, right? That's the main question. I created this model to make the best possible or optimal decision for myself. And by solving this problem, I'm going to decide what is the optimal number of tables to produce, what is the optimal number of sofas to produce to maximize my profit. Okay, that's the big question that we are going to answer. All right, so thank you so much for watching this video, and I will see you in the next one.